This is Jacob Holsopple with Sports Science. We're here on the baseball diamond to explain our rate of change calculus problem. Here we go, boys.
Go.
We're here in the lab to do some calculations. Kick it to Bryce.
Examples we're about to show you are from section 4.6, related rates. What we've seen most in class had to do with this year was the problems we did with a ladder up against a house where we were trying to find how fast the distance between 2 points was changing. To show you how we found that, let's go to Professor Max.
Alright, so our goal today is to find the rate of change of the distance between the runner and home plate when he's exactly halfway to second. So here I'll draw a little diagram. There you got second base. That is home plate. That's first base. So right here, we have this distance first base. Then we have here, that's halfway, that's what we're going to measure here. Then we got that distance from home, right here. And this line right here will make a right triangle. This distance we know to be 90 feet because we are educated on the dimensions of baseball. And this distance right here, 45 feet, exactly halfway from first to second. So our first step in this problem is to set up an equation we can use to find the rate of change. So over here, I'm going to do a little Pythagorean theorem, x squared plus y squared equals z squared. So we got x, here we got y, here we got z. So we'll do 90 squared plus 45 squared equals z squared. So figuring this out with a calculator, you get z is equal to 100.623 feet. So then we can fill this in over here. Now what you want to do is we want to take our equation, our Pythagorean theorem equation that relates all of the sides of the triangle to each other, x squared plus y squared equals z squared. And then what we're going to do is we're going to find the derivative of this equation. So that comes out to be 2x dx dt plus 2y dy dt equals 2z dz dt. And these dx dt, dy dt is the derivative of x with respect to time and derivative of y and so on. So these right here, these variables, dz dt, dy dt, and dx dt will be our rates of change of the different sides. And ultimately, we're trying to find the rate of change of the distance from home to halfway from first to second. So that right there is dz dt. And that's what we're trying to find here. Alright, so in our problem, it gives us that the rate of change of the runner from first base to halfway to second base is equal to 10 feet per second. So here, that's dy dt. In other words, the rate of change from first to second. And down here, the rate of change from home plate to first base would be dx dt. And dx dt is 0 in this problem because the distance from first base to home plate is not changing throughout the problem at all. So that's equal to 0. And over here, dz dt, that's what we're trying to find. So dz dt, we don't know. Alright, so now we have all of our variables and the numbers, what we're trying to find out, and an equation to plug them all into. So the next step is to plug and chug, plug the numbers in and see what we get. So we have 2x, and x is equal to 90 feet. And then dx dt, the rate of change, is equal to 0. Plus 2y, and y is 45 feet, times dy dt, which is 10 feet. And that equals 2z, which is right here, 100.623 feet, times our rate of change from home plate to the runner halfway between. So that is a question mark. That's our variable. So now we plug in the formulas. This will cancel out right here because the x dt equals 0, so that makes it equal to 0. So right now we'll have 2 times 45, 90, times 10, 900. So we have 900 is equal to 2 times 100.623, which is 201.246 feet. And that will be times dz dt, our variable. So then all we do is divide 201.246 on each side. And that will equal dz dt. And in this problem, that will come out to be 4.472 feet per second. So in conclusion, our runner from first to second base, when he is halfway in between the bases, his distance from home plate is changing at a rate of 4.472 feet per second. And in our problem, in this respective problem, it was plenty of time for our catcher to be able to gun him out at second base. This has been another episode of Sports Science. I'd like to thank you for watching and hope you have a nice night.
Stop.